In this lesson, we're looking at developing a formula for the surface area of a sphere. And in order to do that, we're kind of starting with volume and working away from volume into surface area, and I'll clarify what I mean by that. What we're doing is we're considering the volume of the sphere to be made up of the volume of a whole lot of very small pyramids inside this sphere. And the pyramids all have a height equivalent to the radius of the sphere, and the bases of the pyramids are all parts of the surface of the sphere. So first thing they're asking us is, what is the approximate volume of each pyramid? So remember that the formula for the volume of a pyramid is V equals 1/3 B times H. So if the height of each pyramid is R, I can just rewrite that as 1/3 B times R. And express the approximate volume of the sphere in terms of N pyramids. So the volume of the sphere would be 1/3 B times R times that number of pyramids. Let's call it N. Now they're asking us to use the formula for the volume of a sphere to write an approximate equation that would be solved for B. Well, let's think about that. The volume of a sphere is 4/3 pi r cubed. And in this equation, we have 1/3 BRN. All right, so then that means that if I multiply both sides of the equation by 3 in order to get rid of the fractions, that means that 4 pi r cubed would equal B times R times N. And if I were to simplify that a little bit further, that means I can divide both sides by R and get 4 pi r squared equals the area of all of those bases times the number of bases. Well, remember that the bases of those pyramids were parts of the surface of the sphere. So now it's saying write an approximate expression for the sphere's surface area in terms of the pyramid's bases. So the surface area of the sphere would be base of each pyramid times the number of pyramids. And so since here I know that Bn is 4 pi r squared, that means that the surface area of a sphere is 4 pi r squared. As n gets larger and larger, what do you think will happen to the closeness of the approximations in steps A, B, C, and E? They will get closer and closer to the true surface area of the sphere. So once again, S would equal 4 pi r squared. And lo and behold, here it is as our official formula. And so in example 1, part A, let's use that. In example 1, I have a spherical water tank with a 21.5 foot diameter. So that's why you see the first thing that they did here is take half of that in order to find the radius. And since this problem is talking about covering this sphere with a corrosion-resistant alloy, and it's giving the thickness of that alloy in terms of inches, that's why you see them converting into inches. So my radius I want in terms of inches, so when I plug into the formula 4 pi r squared, I'm plugging in 129 inches. And so in my calculator now, I have 129 squared times 4 times pi, giving me 209,117 approximately square inches. Then it says to find the amount of alloy to the nearest cubic inch. So it says that the amount of alloy is the surface area times the thickness. So my surface area again is 209,117 times 1/8. And when I multiply by that, I get 26,140 approximately cubic inches. Here I have a basketball. I am given the circumference of the basketball and the circumference of a baseball, and then I'm asked to find how much material is needed to make each ball. And so it looks like I accidentally cut off question 4 where it's asking how much material is needed to make the baseball, so we'll find that as well. First though, we got to work backwards from circumference in order to find the surface area. So remember that circumference is 2 pi r. So for a basketball, 29.5 is equal to 2 pi r. So in order to figure out what r is, I'm going to divide both sides by 2 pi. So in some of your calculators, you might need to do this in 2 separate steps, meaning you would do 29.5 divided by 2 equals and then divide by pi. In some calculators, you can put parentheses around what you're dividing by. Just be very, very careful that your answer makes sense. So 29.5 divided by that 2 pi gives me that my radius is approximately 4.7. So now the surface area of the basketball is 4 pi times 4.7 squared. So 4.7 squared times 4 times pi is 277.6 square inches. And again, I apologize that on my screen I've cut off number 4, but you should have it in your textbook. Let's go ahead and find that. So again, I have to work backwards from the circumference in order to find the surface area. So circumference of a baseball is 9, and that equals 2 pi r. And so I'm going to divide both sides by 2 pi. And that means that my radius is approximately 1.4. So S is 4 pi times that 1.4 squared. Giving me approximately 25.8 square inches. In this composite figure, we're finding the surface area. Let's break it down. I need to find the area of the base. I need to find the lateral area of the cylinder, and then I need to find the surface area of a hemisphere. So I'm given the radius of the cylinder, which is also the radius of my hemisphere. I'm given the height of the cylinder, so I'm given everything I need. So let's just plug the values in. And you see in part A, they've already found the area of the base of the cylinder. Next, I'm going to find the lateral area of the cylinder, so that's 2 pi RH. And when I type that into my calculator, that's 14 times 5 times 2. That's 140 pi. The surface area of the hemisphere will be 2 pi r squared. So 2 pi times 5 squared is 50 pi. And since everything is in terms of pi, let's keep it in terms of pi until the end. So the first area was 25 pi. I'm adding that to 140 pi plus another 50 pi. And when I evaluate that, I have 215 pi, which is approximately 675.4. Surface area of this composite figure. Notice that it's asking for it in terms of pi and to the nearest tenth. So they've broken it down for us. We're going to find the lateral area of the cylinder, the surface area of each hemisphere, and then the surface area of the composite figure. Well, instead of finding the surface area of each hemisphere, let's consider the fact that if I take two hemispheres and put them together, then it's just a sphere. All right, so lateral area of the cylinder is 2 pi RH, so that's 2 pi times, be careful, notice that they've given us 8 is the diameter, so my R is 4, so 2 pi times 4 times 5, which is 40 pi. The surface area of the sphere would be 4 pi r squared, which would be 4 pi times 4 squared, which is 64 pi. And when I add that together, I get 104 pi square inches, which is equivalent to approximately 326.7.